Hi, so we'll be presenting on how we resolve cross-source duplication in our movies lakehouse by creating a universal movie identifier in BigQuery. This was the most technical, complex part of projects 4 through 6 for us, where we had to unify conflicting movie records coming from 6 different data sources. Really quick for our agenda, we're going to be walking through the problem statement, which data sources we had to unify, why this broke the lakehouse, our solution and the architecture, some demos, and then some key takeaways that we had.
Yeah, so one of the main problems we faced was that the same movie could show up with different titles, attributes, and IDs, and since the data came from 6 providers, there were very different identifiers and even duplicate and redundant data. One of the biggest things was anomaly 9 violations, where different data sources, like movies coming from different providers, would have some things in common, but other things not. And it was up to us to decide how to join them together and how to merge these duplicate identifiers. For example, some movies use the same title, some use a different title, like through IMDb, and some had no unique ID at all, which made it very hard to refer to them. So it was very hard to enforce primary keys or foreign keys, and thus before the MART layer, we needed a single source of truth for movie identity. And checking slides, cool. And for the data sources we had to unify, first, we have our IMDb dataset, which was CSV, Best Picture CSV, YouTube trailer sentiment, which is a scrap JSON, which we had to then convert. Movie posters became in the form of a bucket for BigQuery, and the soundtracks and platforms were also in CSV form. Through all of these, we had to join all the movies based on the primary key, which we found to be the title. And as you can see in the column 3, there were a lot of different ways these data sets used to refer to the movie's title from these, different providers. And every source had a different movie name field. Some had capitalization differences, some included punctuation, some had irrelevant words before the actual title, like The Great Gatsby or A Wrinkle in Time. So, in the end, we chose to use IMDb ID because that provided a good global reliable data identifier that didn't have all these different things getting in the way. Next slide. Cool. So, why does this break the lake house? Because primary keys can't be enforced this way, and aggregations that will start double counting the records, which is not what we want when we're doing things like the mathematical operations and finding the averages. And as a result, in our MART layer, it made resolution very impossible, and we had to fix this before analytic modeling. Without a universal ID, every single query became more fuzzy and slow and error prone. You would see inaccurate calculations, and like mentioned earlier, when you try to aggregate records, you can get double counts or counts might be skipped when they actually shouldn't be. And our goal was to eliminate all these errors before building our material layers. Next slide. Cool. And our fix was to create a universal movie key by building a single parent table, which was a movie. Then we decided to generate the key by trimming both the title and concatenating it with the movie year. And titles were then normalized because, as mentioned earlier, they came with a lot of different parts, like deleting irrelevant words, the a and things like that where normally you would want to just take the first most significant word as the actual title. So we had to normalize that, and then we had to make sure all punctuation was normalized by converting everything to uppercase, and that the case, as mentioned earlier, converted to uppercase, and also the spacing was normalized, which we did so as well by trimming the title, making sure there were no off spaces in string itself. And then we use a fuzzy match to get unmapped records because some records were meant to be merged, but they were missed because the algorithm couldn't directly get them. They would fall through the cracks basically. So we had to use this additional method to match them together. And then we used LLM models to infer missing mappings because I said earlier, some actually did fall through all the filters we had. And in the end, we rebuilt the child tables to reference by the movie key instead of the name or title of said movie. And we chose this because the key exists in every data set and can survive formatting differences, with our algorithm we used above for the string manipulation. And this gave us a 92% match right away, and the remaining 8% required machine learning and large language model assistance. Cool, and onto a demo.
Great, yeah. So now I'm going to walk us through a few code snippets that just kind of show some of the things that we talked about in our solution and our approach. So the first one right here, basically what we're showing is that we discovered that the same movie could appear multiple times inside of a single source. And this kind of made the title and the year not a reliable primary key, which is why we decided to create a universal movie key. So the next demo over here is showing that some of our joins were failing earlier, not just because of a text mismatch, but also because the fields were not typed consistently. So for example, like in the int layer, the year key was stored as a string because it came from multiple sources. So in this code snippet, we went ahead and we safe casted it to an integer so it could match the dataset fields of something like year of release. Now, instead of us having dozens of null rows, we would instead get one unified record per movie, which is what you can see in the output over here. On to the next code snippet. Over here, we're basically showing that we're collecting all of the distinct title plus year combos from three different source tables, and then we're normalizing the year field into a string because some of the sources were stored differently. And then finally, we generate a stable SHA-256 hash as a global primary key, and then we write the result into the int layer table called movie ID map. And then a final snippet that I wanted to show was basically that over here, this query that's written is a primary key validation check on our movie sentiment scores table. So we go ahead and we group by movie key and sentiment type, and we look for any cases where the count is greater than one. Because the result returns 0 rows, as you can see down here, it confirms that our int layer successfully removed duplicates and that the new primary key is actually holding. In staging, the same check would have shown us dozens of violations, but after the anomaly cleanup and the key creation, the table is now relationally valid. Moving on to just a quick pipeline overview and kind of the architecture of like what we developed. So again, we started with our staging tables. We went to the mapping layer, had embeddings, used an LLM inference, then went to our int layer, and finally the MART layer. Two of the big things that we accomplished here were that anomaly 9 was resolved, which means a shared identifier now exists across all the tables, and then anomaly 10 was also resolved, which means that the child tables reference parents instead of duplicating attributes across multiple tables. So yeah, overall, this is where we implemented our deduplication, identity creation, and forced referential integrity. All of these things that were required before building the tables in Project 7. One more thing we want to show is our ERDs before and after Project 6. So just, I guess the main thing to call out here is that on the left is our staging layer, and there's no shared movie identifier. You can see that, there's not like one table that is centralizing and serving as like a primary key versus our right ERD is following Project 6. And over there, you can see our int layer, and you can now see that there's a movie primary key, there's clean children tables, and there's foreign key links across tables. Finally, we want to go through some key takeaways. There is a universal movie ID fixed, which fixed the cross-source inconsistencies. We use the LLM and embeddings to fill in the identity gaps. Our primary key and foreign key constraints are now enforcing real integrity. And we meet all the validation criteria, specifically 8, 9, and 10 fully. And this made us ready to do Project 7, which had the analytical and machine learning layers. That's all, and thank you so much.